Hello students, I Surbhat Karwar. Today we are going to take a topic complex number. So first of all, we know that if we write a quadratic equation x square plus 1 which is equal to 0 has no real solutions. Because of further solving this we get x square which is equal to minus 1 and roots of this equation will be under root minus 1. So here we can say if we talk about a discriminant, d is less than 0 of this equation, but we can define the solution of this equation in complex number. Suppose let root minus 1 which is equal to I. I means we can pronounce it iota. So we can give a name to root minus 1 as I or iota. So here we can define the solution of the equation x square plus 1 as in complex number as in the form of iota. So we can say a number of the form x plus iota y where x and y are real numbers. So we can say if we have any number in the form x plus iota y and where x and y are real number, then we can say it is a complex number. For example, if we take example 2 plus iota 3. So it is a complex number and 2 and 3 are belongs to real number. More examples we can take minus 1 plus iota root 3. Similarly it is also a complex number. So here we can say x is real part. X is real part, or we can say REZ, because of we can define x plus iota y as z. Z is equal to x plus iota y, then we can say x is the real part of z or x plus iota y. Similarly y is imaginary part, or we can write it as IMZ. So here z is equal to x plus iota y and x is the real part and y is the imaginary part for z, x, which is equal to x plus iota y. Now if z1 is equal to x1 plus iota y1 and z2 is equal to x2 plus iota y2, z1 is equal to z2 if and only if x1 is equal to x2 and y1 is equal to y2, or we can say if z1 is equal to z2 then 100% x1 is equal to x2 and y1 is equal to y2. For example, we can take example if we have 4x plus iota 3x minus y which is equal to 3 plus iota minus 6, then we have to find the value of x and y. How can we find the value of x and y? So we have to compare the real part with the real part in right hand side, imaginary part of left hand side to the imaginary part of right hand side. So first of all we can write 4x is equal to 3 because of in left hand side 4x is the real part and the right hand side 3 is the real part. So it gives x is equal to 3 by 4. Similarly 3x minus y which is equal to minus 6. Now we know about the x, so we can put the value of x which is 3 by 4 minus y which is equal to minus 6. It will become 9 by 4 minus y which is equal to minus 6. From here we can find the value of y which is equal to 33 by 4. So here the value of x and y. Now we are talking about algebra of complex number, or we can say the operations we can perform on complex number. So here if we talk about that, if we are given z1 is equal to x1 plus iota y1 and z2 is equal to x2 plus iota y2, then z1 plus z2 will be x1 plus x2 plus iota y1 plus y2, which means sum of real part plus sum of imaginary part. So here the addition of complex number satisfying some properties. First property, which is closure. If you talk about the closure property, then we can say Z1 plus Z2 is a complex number. Z1 plus Z2 also a complex number. Similarly, if you talk about commutative property, then we can say Z1 plus Z2, which is 100% equal to Z2 plus Z1. Similarly, if you talk about associative property, then we can say Z1 plus Z2 plus Z3, which is exactly equal to Z1 plus Z2 plus Z3. Similarly, we can find the additive inverse or additive identity. If we talk about additive identity, then Z1 plus 0 plus iota 0. If we add 0 plus iota 0 in Z1, then we get Z1. So additive identity for any complex number is 0 plus 0 iota. Now additive inverse, if we talk about additive inverse, then Z1 plus minus of Z1, which is equal to 0. So additive inverse for any complex number is negative of the same complex number. Similarly, we can find the Z1 minus Z2, which is equal to Z1 plus minus of Z2. For example, if we have 6 plus 5 iota minus 2 minus iota, then we can simplify it in this manner: 6 plus 5 iota minus 2 plus iota, and further we get 4 plus 6 iota. Now we are talking about the multiplication of complex number Z1 into Z2. So Z1 into Z2 we can define is at x1 x2 minus y1 y2 plus iota x1 y2 plus y1 x2. The product of or multiplication of two complex number follows closure law, commutative law, associative law, multiplicative associative law. And if we talk about the multiplicative identity, then multiplicative identity for any complex number will be z into 1 plus 0 iota, which is equal to z again. And if we talk about the multiplicative inverse, then z into 1 upon z, which is equal to 1, or we can write it as z into z inverse, which is equal to 1. So we can say multiplicative inverse for any complex number is inverse of the same complex number. So here if we have z1 upon z2, we can write it as z1 into 1 upon z2, and further we can write it as z1 into z2 inverse. For example, we can take example. If we are given z1 is equal to 6 plus 3 iota and z2 is equal to 2 minus iota, then how can we find 1 upon z2? 1 upon z2 is equal to 1 upon 2 minus iota, and we can rationalize it, multiply in numerator and denominator by 2 plus iota. Further it will become 2 plus iota upon 5, and further we can write it as 2 by 5 plus 1 by 5 iota. So now here we can find the value of z1 upon z2. We can find the value of z1 upon z2, which is equal to z1 is equal to 6 plus 3 iota into 2 plus iota by 5. Similarly, now we are talking about powers of iota. So first of all, iota to the power 1, which is exactly equal to 1, which is exactly equal to iota. Now iota to the power, iota raised to the power 2, which is equal to minus 1. Iota to the power 3, which is equal to iota square into iota. So we can write it as minus of iota, because of iota square is equal to minus 1. Similarly, iota to the power 4, which is equal to iota square to the power 2, which is exactly equal to 1. Similarly, when we find iota to the power 5, we get iota to the power 4 into iota, and again it will become iota. So we can say it is same as iota to the power 1. So we can write a standard form that iota to the power 4k, which is equal to 1, iota to the power 4k plus 1, which is equal to iota, iota to the power 4k plus 2, which is equal to minus 1, and iota to the power 4k plus 3, which is exactly equal to minus of iota. Now we are talking about square root of a negative number. Square root of a negative number, because I square is equal to, or we can say iota to the iota power 2 is equal to minus 1. So we can write it as minus iota to the power 2, which is equal to iota square, which is equal to minus 1. So here under root minus 1, which is equal to iota, or we can say under root of minus 1 is equal to iota, but under root minus 1 we would mean only iota. So here if a is a positive real number, if we talk about a is a positive real number, if a is a positive real number, then under root minus a, which is equal to under root a into under root of minus 1, or we can write it as under root a iota. So here if we talk about under root a into under root b, which is equal to under root ab, it is true for a is greater than 0, b is greater than 0, a is greater than 0, b is less than 0, a is less than 0, b is greater than 0. If a is less than 0, b is less than 0, then under root a into under root b, it is not equal to under root ab, because iota square, which is equal to minus 1 into minus 1. Further, if we can write it as minus 1 into minus 1, it will become 1, which is not possible because of iota square is equal to minus 1. So here we can say for a is equal to b is equal to 0, then under root of a under root of b, which is equal to under root of ab, further which is equal to 0. So here now we have some identities for complex numbers. First of all, z1 plus z2 to the power 2, we can expand it as a plus b to the power 2. Similarly, z1 square plus 2 z1 z2 plus z2 square. Similarly, z1 minus z2 to the power 2, we can expand it similarly as a minus b to the power 2 z2 square, z1 square minus 2 z1 z2 plus z2 square. Similarly, one more formula, z1 square minus z2 square, we can write it as z1 plus z2 into z1 minus z2, z1 plus z2 to the power 3, so it will become z1 cube plus z2 cube plus 3 z1 z2 into z1 plus z2. Similarly, we can make more identities for complex numbers.